Hello. In this video, I'm going to go through a few examples of how to name alkane structures, branched alkanes, and cyclic alkane structures. You should definitely have read through the first lesson packet carefully before you come to this video, because if you have not read that packet and you try to watch this video, things are probably going to go a little too fast for you. Also, there are going to be 3 questions that I'm going to get to during the course of this video. I'm not going to be solving these questions. You are, and you're going to upload your answers to Schoology a little bit later. So when I get to the 3 different questions, you may want to pause the video, copy down the structure in your notebook, and then solve it in your own time before you put your answers into Schoology. All right? So let's get right to it. Let's take a look at this first structure I have here on the board. So this, hopefully, after you've read the packet, looks like a fairly straightforward version of a branched alkane. The specific issue this example brings up is that you do not default to numbering alkanes simply left to right. The idea is you want to make sure that you find the lowest number possible for that first branching point. If I numbered left to right, my first branch would not occur until I get to carbon 1, 2, 3, 4. But if I numbered right to left, I would run into that branch at 1, 2, 3. So I'm going to want to number this structure right to left. So that's going to be carbon 1, that's going to be carbon 6 of the parent chain or the main chain. Remember, the first object of the game is to find the longest connected series of carbon atoms to make up the parent chain. And so that means that my branch here is on carbon 3. And that's the only branch. So this structure is going to be based on hexane, and I'm going to have a 1 carbon branch at the 3rd carbon. So the overall name for this structure is then going to simply be 3-methyl. Notice the use of the YN and YL ending for that branch, and then it's a hexane. HEX for hex for our 6 carbons, and then the ANE ending for the fact that it's a alkane, meaning that all the carbons are singly bonded to each other. So there we go, that's 3-methylhexane. Let's look at a slightly more complicated example. Again, the first object is to find the longest connected series of carbons for the parent chain. So if I start over here, I have carbon 1, 2, 3, 4, 5, 6, 7, 8. Or if I start here, 1, 2, 3, 4, 5, 6, 7, 8. So those 2 would be the same length of carbons. And in both cases, 1, 2, 3, the first branch here is at carbon 3. Or 1, 2, 3, the first branch would be on carbon 3, and they would both be ethyl branches. All right, so I'm going to start the numbering for this guy starting on the left. So this is going to be carbon 1, and then I had 1, 2, 3, 4, 5, 6, 7, 8 carbons in total in the parent chain. Now, so far I've made it easy. The parent chain is on the horizontal, as it were, going left to right or right to left. We'll see in future examples that that's not always the case. Sometimes the parent chain can kind of go left to right or top to bottom or kind of diagonally. So you're just looking for the longest connected carbon chain, no matter which way it ends up going. So then on carbon 3, I have a branch. On carbon 4, I have a branch. And on carbon 5, I have a branch. Now, when you have to write the full name of this out, I kind of tend to find, at least when you first initially learn this stuff, it might be easiest to go ahead and name the branches kind of near where they are. So for example, this guy here on carbon 3, right, that is going to be a 2-carbon chain, so that's going to be an ethyl branch. At carbon 4 here, I have a methyl branch for 1 carbon long. And on carbon 5 here, this is one of those common complicated branches that the notes mention. This is referred to as an isopropyl branch. All right, and when I list these branches in the name, I'm going to have to list them alphabetically. So the E of ethyl will come before the I of isopropyl, which will come before the M of methyl. So I'm going to list them in alphabetical order, not numerical order. Okay, the numbers will be what the numbers are, but when I list all of these branches in front of the name, in front of the parent chain name, I have to list them alphabetically. So that means that I am going to then have 3-ethyl hyphen, next would be 5-isopropyl, and next is my 4-methyl. Going to just shrink this down a little bit so the rest of the name is going to fit. And then it's an 8-carbon chain, so then this is going to be octane. OCT is for 8 carbons, ANE again, because all the carbons are singly bonded. So the full name of this is 3-ethyl 5-isopropyl 4-methyl-octane. See that? It just kind of rolls right off of the tongue. So some key things to note about the syntax of the name. There are no spaces in this name. At no point, if I were typing this out, would my thumb hit the space bar as I typed the name out. I have hyphens that offset letters and numbers, and that's basically it. Again, no hitting of the space bar. Not yet. There are some names that do involve spaces, but we won't see them for a little bit longer. Okay, so here's the first question. I'll go ahead and make it a little bit bigger. You might want to hit the pause button on the video, copy this down, and go ahead and start preparing your own answer for the name here. I'm going to move on to the next example I will complete for you. Okay? All right, so here's our first example involving a cycloalkane. Right? So we have the longest continuous carbon chain is in a ring. Now you're going to want to pay special attention to the notes on this section because there's the right way to count the connected carbon atoms and there's the wrong way to count the connected carbon atoms. So make sure you're abiding by the rules for counting carbon atoms in a chain when it comes to cyclic structures. All right, so I could have carbon 1 here, 2, 3, 4 as I go around the ring, or I could have carbon 1 here, 2, 3, 4. Now, what I should do is I should give some priority to what would then be the alphabetically first group. So I'm going to go ahead and begin the numbering here down on the bottom right. That's going to be carbon 1, this carbon right here of the cyclohexane chain, because that's an ethyl branch. Right? This is an ethyl branch, E for ethyl. This is a methyl branch. So since either way I go would be 1, 2, 3, 4 for the branches, or 1, 2, 3, 4 for the branches, since the number's the same, I'm going to give priority here to this alphabetically first group. So on carbon 1, I have that ethyl group. On carbon 2, I have a methyl group. Carbon 3, I'm going to have another ethyl group. And carbon 4, another methyl group. And the whole thing is cyclohexane. Now you'll notice here I'm bringing up a slightly new version of our naming rules, and that is I have 2 ethyl groups and I have 2 methyl groups. So I'm going to be using the prefix di, di, in front of both my methyl and ethyl branches. All right, so the name of this fellow then is going to be 1, 3 hyphen diethyl hyphen 2, 4 hyphen dimethyl. And just to fit the rest of the name in, I got to shrink things down a little bit, maybe a little bit more. And so then this is going to be cyclo, I put in the cyclo prefix, cyclohexane. All right, so the whole name, it's a 6-carbon ring, so there's my hex, all singly bonded, there's my ane. The alkane is cyclic in nature, so there's my cyclo. And then I have 1, 3, so there are 2 ethyl groups at the 1 and 3 position, 2,4-dimethyl, so I have methyl groups at the 2 and 4 position. So again, 1,3-diethyl, 2,4-dimethyl, cyclohexane, and the E of ethyl comes prior to the M of methyl. These numerical indicating prefixes like di, I could also have tri for 3 and tetra for 4. Those numerical indicating prefixes would not be counted when I lay out the alphabetical ordering of the name. All right, here's question number 2 that I would like you to work on your own. You might want to pause the video here so that you can go ahead and copy it down. All right, let's move on to the next page of solved examples and some problems. So here now I have a structure that is involving cyclic groups and non-cyclic groups. And the objective here is you have to do a little bit of counting. So I have 1, 2, 3, 4, 5, 6, 7 carbons in the non-cyclic portion. I have 5 carbons here, 6 carbons there. So the parent chain is going to be the 7 carbons that are not cyclic. They're acyclic, I guess we could call them. And my first branching point is going to be on carbon 2 here. So I'm going to number this fellow going in that direction, sort of right to left or diagonally top right to diagonally bottom left. So we have carbon 1 here. I have a branch on carbon 3. I have a branch on carbon 4. And then 5, 6, 7, I have 7 total carbons in the parent chain. And at 3, my branch is a cyclopental group, cyclopental. And 4 here, this is one of those common complicated branches that the notes mentioned. This is referred to as a phenyl group. Okay. Some of you may recognize this structure as a benzene ring if you've taken organic chemistry or you've paid attention to some of the terminology in your core chemistry classes. That's a benzene ring, and it's being used as a branch off of a longer chain. All right, so let's then go ahead and give the full accounting of the name here. The C of cyclo, that will be included in the alphabetical ordering. So my name here is going to then be 3 cyclopental, 4 phenyl. And then let me shrink again so I can fit the rest of the name in. What do we have here? We have here heptane. H-E-P-T, heptane, A-N-E. So hept for the 7 carbons in the parent chain, A because they're all singly bonded, 4 phenyl for that 4 benzene ring branch off of carbon 4 of the main chain, and then 1, 2, 3 cyclopental. So 3 cyclopental, 4 phenylheptane again. These names just roll off the tongue once you get used to saying them. All right, here's question 3. This one's a little bit longer and a little bit more complicated, so pause the video, copy it down so that you can provide your own answer and you can upload it to Schoology when you have a chance. All right. What I'm going to do last here is I'm going to take a look at drawing a structure. So everything I've done now has been me looking at a structure and deriving the name. What we're going to do here is I'm going to be given a name and I'm going to draw the structure. I think there's a little bit of an analogy here to a world language. When you're learning a world language, you sometimes go from your native language to the world language, and sometimes from the world language back to your native language. Now, I don't know about you, but when I learned world languages, I always found it a little bit easier to be given the world language and work my way back to my native language. So, for example, when I learned Spanish, I always found it easier to go from Spanish back to English because I just had to kind of work my way through the Spanish without having to worry about kind of creating the thoughts in Spanish. So to me, I think when it comes to structure stuff, in a way, I think it's easier to be given the name and then draw the structure. Because in a way, the name has all the instructions right there. Just draw what the name tells you to draw. Whereas if I'm given a structure and I have to derive the name, I kind of feel like that's a little bit harder to do because I have to make sure that I'm tracking all of these different rules of nomenclature as I pull the name out of the structure. So when I draw structures based on name, I kind of like to work my way from backwards to front, right? Because the parent chain information is always sort of in the caboose of the name. So just start back here, draw what that says, and then add on the decorations of the branches as you go through. So I have to draw an octane chain. All right, so 2, 3, 4, 5, 6, 7, 8. All right, so when you draw these out, just remember that first line you draw, that's 2 carbons. So 1, 2, 3, 4, 5, 6, 7, 8. So there are my 8 carbons. All right, and then follow the directions. I'm going to shrink this down just a little bit. Then follow the instructions. So I have 3 phenyl. So on carbon 1, 2, 3, 1, 2, 3, right there, we're going to put a phenyl ring. So a line to the 6 carbons of the phenyl ring, and it has alternating double and single bonds. I didn't spend a lot of time talking about that when we first saw phenyl in this video, but those double lines mean that the carbons are connected with 2 bonds. You should convince yourself, as the notes say, that the structure of a phenyl branch, it has the formula C6H5. All right, so that's on carbon 3. On carbon 4, I have to put an ethyl branch. So 1, 2, right? So there's my 2 carbons. So just to be clear, right, this is the line right here that's connecting the parent chain carbon to the first carbon of the branch. So that line is the first bond to the 1 carbon, and then I need another line to represent the bond to the second carbon. All right, and then I have to count out. So 1, 2, 3, 4, 5, 6. So right here, I'm going to want to put my methyl branch. So right there, I put my methyl branch, and I'm done. Okay, so the reason this is 4-ethyl, 6-methyl, 3-phenyl is that when I go left to right, my first branching point here would be 3. If I go this way, my first branching point would also be 3, but because of the third branching point that I have to have that at carbon 4, I will be numbering this left to right so that I get lower numbers overall, okay? You only have to appeal to the alphabetical idea of the branching points if all the numbers would be the same. Numbering left to right here gives me different numbers, 3 and 4, followed by 6. If I numbered right to left, I would have 3, 1, 2, 3, 5, 6. Yeah, so my numbering would be different if I went right to left. All right, so you will also have to practice being given names and drawing the structures. Again, I find that a little bit easier, at least intellectually, but it does take some practice on how to draw these structures. So you will want to do that deliberate practice in drawing the structures. All right, so that's all for this video. Again, put in your answers for those 3 questions, and we'll pick up with our next lesson soon.